Have you ever looked at a piece of tech and wondered, why does it work exactly like this? Why isn't every camera lens absolutely perfect, or every medical sensor instant? Well, in this explainer, we're going to pull back the curtain on the hidden decisions and, honestly, the brilliant compromises that make all of our technology possible.
So, let's start with the big question. Why isn't every sensor just perfect? The answer isn't a lack of trying or some failure of imagination. Oh no. It's actually this fascinating, high-stakes balancing act that engineers perform every single day, working inside a strict set of rules to create the best possible thing they can.
Okay, so here's our game plan. First, we'll talk about that quest for perfection, the ideal goal. Then we'll get into the rules of the game that engineers have to follow. After that, we'll explore the art of compromise, see the engineer's balancing act in action, and finally, we'll connect all of this back to the devices you literally use every day.
Right, so before we can even talk about compromises, we really need to understand the mission. At its absolute core, what is a sensor even trying to do? What's its one true job?
In a perfect world, this is it. A sensor's only job is to detect something out there in the real world, like light or heat, or maybe a specific chemical, and then translate that information flawlessly into a signal a computer can read. Seems simple enough, right? Well, yeah, not so much.
So why isn't it that simple? Why can't we just build that perfect sensor? Well, it's because engineers aren't working in a fantasy land. They're operating within a very specific, very real set of rules. And these are called design constraints. Think of a design constraint as the official rulebook for any engineering challenge. These are the lines you just can't cross. They're the non-negotiables. You can't, for example, break the laws of physics, and you definitely can't spend more money than you have in the budget.
And this list of rules can get really, really long. We're talking about everything from the basic physical properties of materials you can use to the environment it's going to live in. And then you have the super practical stuff like cost, size, how much power it uses. It's this whole complex web of limitations.
So, if you can't break the rules, the constraints, what do you do? Well, this is where you have to get clever. This is where the real art of engineering shines through, and it is all about making smart compromises. We call them trade-offs.
A trade-off is the #1 strategy for dealing with constraints. It's a conscious, strategic decision. It's saying, okay, I am going to make this feature a little less powerful so I can make that feature way better. It's all about making a strategic sacrifice for the greater good of the final product.
Let me give you a classic example. Sensitivity versus noise. You can design a sensor to be incredibly sensitive, right? To pick up the absolute tiniest changes in the environment. But here's the trade-off. The more sensitive it is, the more likely it is to pick up random environmental noise, like stray electrical signals or tiny vibrations, which can lead to totally false readings. Or how about this one? Range versus resolution. Let's say you build a thermometer that can measure a huge range of temperatures, from freezing cold all the way up to 1,000 degrees. That's an amazing range. The trade-off, though, might be that it can't tell the difference between 70.1 degrees and 70.2 degrees. You sacrifice that super fine detail, the resolution, to get that massive range. So here's the crucial thing to remember. Engineers are almost never making just one trade-off. It's a constant, incredibly complex balancing act. They're juggling dozens of these competing factors all at once, trying to find that perfect sweet spot. This table gives you a little peek inside an engineer's brain. They are constantly weighing technical performance, things like accuracy and response time, against very real-world problems. For sure, using some amazing high-performance material might boost accuracy, but it's also going to make the cost skyrocket. A super complex design might be revolutionary, but can you even build it in a factory? Okay, so let's bring all this back home. Why does this whole intricate dance of constraints and trade-offs actually matter? Well, because it has a direct, tangible impact on the technology you depend on every single day.
Seriously, think about it. Every time a medical scanner gives a doctor a crystal clear image, every time the safety systems in your car kick in, every time you check the weather on your phone, you're experiencing the end result of thousands of these smart trade-offs. These decisions are what make our tech not just powerful, but also affordable, reliable, and, possible in the first place.
So the next time you pick up your smartphone or use any smart device, just take a second and think about it. What invisible compromises, what clever balancing acts had to happen for that amazing piece of technology to even exist in your hand?
What you're really thinking about is the art of engineering itself.